5 amazing scientific phenomena caught on video. Before we start, I would want you to hit that red subscribe button so that you never miss out on any of our videos. Number 5. Volcanic shockwave. A volcanic eruption is just about the most powerful explosion that humans are likely to see on Earth. In seconds, energy equivalent to multiple atomic bombs can launch thousands of tons of rock and debris miles into the air. Best not to be too close when that happens. However, some people are inquisitive about these things and will linger near an erupting volcano to record a video of it. In 2014, Mount Taverver in Papua New Guinea exploded. Luckily for us, people were there to film it. As the volcano blew, a shockwave could be seen traveling upward into the clouds and outward toward the observer. It broke over the boat like a thunderclap. The explosion that produced the shockwave was probably caused by gas building up within the volcano, as magma blocked its escape. The sudden release of this gas compressed the air around the volcano and produced the wave that rocketed out in all directions. Number 4. Volcanic lightning. When Mount Vesuvius erupted in AD 79, Pliny the Younger observed something strange about the explosion. There was a most intense darkness rendered more appalling by the fitful gleam of torches at intervals obscured by the transient blaze of lightning. This is the first recorded mention of volcanic lightning. When a thunderous cloud of dust and rock is propelled into the sky by a volcano, huge bolts of lightning can be seen dancing around it. Volcanic lightning does not occur with every eruption. It is caused by a buildup of charge. In the heat of a volcano, electrons can be easily kicked off an atom to produce a positively charged ion. Electrons can also be transferred by collisions between dust particles. The electrons can then attach to other atoms to make negatively charged ions. From the different ways that the ions move due to the size and speed, a buildup of charge can occur across the plume of the eruption. When the charge is sufficiently high, it will transfer from one region to another in the blisteringly fast and hot bolts of lightning seen in the video above. Number 3. Levitating frogs. Each year, the Ig Nobel Prizes are awarded for research that makes people laugh and then think. In 2000, Andre Geim won the Ig Nobel Prize for levitating a frog using magnets. His curiosity had been piqued when he poured some water directly into a machine with powerful electromagnets around it. The water clung to the walls of the tube, and droplets even began to float. Geim had discovered that magnetic fields could act strongly enough on water to overcome the Earth's gravitational pull. Before this, diamagnetic materials, those without an overall magnetic field, were thought not to interact much at all with magnetic fields. Geim moved from water droplets to live animals, including frogs. These could be levitated because of their water content and led to some bemused-looking animals in strong magnetic fields. The sting of winning an Ig Nobel Prize was somewhat lessened when Geim won a real Nobel Prize for his part in the discovery of graphene. Number 2. Laminar flow. Can you unmix a liquid? It turns out that you can under certain conditions. If you pour orange juice into water, then it is unlikely that you will ever separate the two. But using dyed corn syrup as shown in the video above, you can. This is due to the special properties of syrup as a fluid and what is called laminar flow. This is a type of movement within fluids where layers tend to move in the same direction as each other without mixing. This example is a special type of laminar flow, known as Stokes flow, where the fluid used is so thick and viscous that it barely allows any diffusion of particles. The mixture is stirred slowly, so it does not form any turbulence that would really mix the colored dyes together. It only appears that the dyes mix because light is passing through the layers that contain the separate dyes. Slowly reversing the mixing brings the dyes back to their original positions. Number 1. Cherenkov radiation. You might think that nothing moves faster than the speed of light. Indeed, the speed of light does seem to be a speed limit in this universe that nothing can break, as long as you are talking about the speed of light in a vacuum. When light enters any transparent medium, it slows down. This is due to the electronic component of light's electromagnetic waves interacting with the wave properties of electrons in the medium. It turns out that many objects can move faster than this new, slower speed of light. If a particle enters water at 99% of the speed of light in a vacuum, then the particle will overtake light, which only travels at 75% of the speed of light in a vacuum in water. And we can actually see this happen. When the particle passes through the electrons of the medium, light is given off as it disrupts the electronic field. A nuclear reactor in water glows blue because it is flinging off electrons at such high speeds, as seen when the reactor is activated above. The eerie glow of radioactive sources is even cooler than most people think. This brings us to the end of our video. I hope you enjoyed it. Hit like if you did, and don't forget to subscribe to our channel so so that you don't miss any of our videos in the future. Also, watch the 2 videos that are on your screen because I'm sure you'll love them. With that, I'll see you in the next video.